Hello everybody, I'm Mrs. Madhavi Salodkar. I'm going to take lecture 3 for theory of attributes for SY BCom students. So we will see the definition of independent attributes. Definition: attributes A and B are said to be independent if and only if frequency of class AB is equal to frequency of A into frequency of B upon n. If this condition is satisfied, then we say that attributes A and B are independent. See the example based on this concept. Test whether the attributes A and B are independent. Given that AB is equal to 10, A beta is equal to 30, alpha B is equal to 40, and alpha beta is equal to 120. We have to find the remaining frequencies. To find the remaining frequencies, we put the frequencies in the tabular form as A alpha total, B beta total, and value of n. So we don't have value of n at this moment, so we'll replace all the class frequencies. Value of AB is given as 10, so AB value is 10, A beta value is 30, A beta 30, alpha B is 40, we'll replace alpha B by 40, and alpha beta is equal to 120, so alpha beta value is 120. To find frequency of class A, 10 plus 30 will give you 40, 40 plus 120 will give you 160, 10 plus 40 is nothing but 50, so frequency of class B is 50, 30 plus 120 is equal to 150, so frequency of class beta is equal to 150. Now we need to check the condition. We need the value of A, value of B, value of AB, and value of n. So replace the values in the condition. A into B upon n. So value of A, frequency of class A is 40, so 40 into frequency of class B is 50, 40 into 50 upon 200. So if you cancel 0 with 0, this 0 is also cancelled with this 0, so 2 ones are 2 twos are, so 5 twos are 10, so frequency of AB is equal to 10. So the condition is satisfied, hence attributes A and B are independent. Next example, out of 800 students, 320 are married. Among 240 students who failed, 96 were married. Find whether the two attributes, marriage and failure in the examination, are independent or not. So let us define the two attributes. Let A denote that the student is married. Naturally alpha will be student is unmarried. B failed student. Naturally beta will be past candidate. So list the things which are given in the problem statement. N is equal to 800. Frequency of class A is 320. What we have defined? A as married student. So 320 are married. So frequency of class A is equal to 320. Frequency of class B is equal to 240. And frequency of class AB is equal to 96. So these four values are given to us. We will check the condition. Frequency of A into frequency of B upon capital N, that is equal to 320 into 240 upon 800. 0, 0, 0, 0 cancels. This 0 cancels with 0. 8 ones are 8 fours are, and 24 fours are 96. So value of AB is 96 only, given value. So the condition is satisfied. Which condition? Frequency of A into frequency of B upon capital N is equal to AB. This condition is satisfied. Therefore, the two attributes, marriage and failure in the examination, are independent. Just like independence of attributes, we have two more conditions: association and dissociation of attributes. If the attributes A and B are independent, then AB is equal to frequency of A into frequency of B upon N. This condition we already have seen in the previous examples. Now, positive association of two attributes. Attributes A and B are said to be positively associated if frequency of AB is greater than frequency of A into frequency of B upon N. Same way, negative association of two attributes. Attributes A and B are said to be negatively associated, or we call it as dissociated, if frequency of AB is less than frequency of A into frequency of B upon N. See the example based on these conditions. Find if A and B are independent, positively associated or negatively associated. The data is given. N is equal to 1000. Frequency of A is equal to 470. Frequency of B is equal to 620. And frequency of AB is equal to 320. First of all, find the value of A into B upon N. So value of A is 470, value of B is 620, and N value is 1000. So 470 into 620 upon 1000, the answer is 291 upon 4. But value of AB is 320. So 291 upon 4, 291.4 is less than frequency of AB. Therefore, attributes A and B are positively associated. Next example. Find if attributes A and B are independent, positively associated or negatively associated. Frequency of AB is equal to 256. Frequency of alpha B is equal to 768. Frequency of A beta is equal to 48. And frequency of alpha beta is equal to 144. See, these class frequencies are given to us, but for checking the condition, we need the value of frequency of A, frequency of B and capital N. So to get these three values, we put all the values in the tabular form and find the remaining frequencies such as frequency of A, frequency of B and capital N. So write down the table: A alpha total, B beta total. Value of AB is given as 256. Value of alpha B is given as 768. Alpha B, 768 value is given. A beta value is 48. So A beta value is 48. Alpha beta value is given as 144. So replace alpha beta as 144. Now to calculate A, we will have to add AB plus A beta. So 256 plus 48 will give you frequency of A. So frequency of A is nothing but 304. To calculate frequency of B, we will add AB plus alpha B. So 256 plus 768. The frequency of class B is 1024. And capital N is to be calculated. Now they have, first of all, get the value of alpha. 768 plus 144 will give you 912. So 304 plus 912. Value of N is 1216. So frequency of A is 304. Frequency of B is 1024. And value of N is 1216. And value of AB is equal to 256. So we'll check the condition. Frequency of A into frequency of B upon N. So 304 into 1024 divided by 1216. So if you calculate the value, so 304 into 1024 upon 1216, the value is coming as 256, which is equal to AB. So what can we say? Frequency of A into frequency of B upon N is equal to frequency of class AB. Therefore, attributes A and B are independent. Next example. For the following data, find out whether the attributes A and B are independent, associated or dissociated. The values of N, A, B and AB are given. N is equal to 100. Frequency of class A is equal to 40. Frequency of class B is equal to 70. And frequency of class AB is equal to 30. So we will find frequency of A into frequency of B upon N. So 40 into 70 upon 100. 0 and 0 gets cancelled with 2 more zeros in the denominator. So 7 4s are 28. So this equation gives us value 28. Our value of AB is 30. So we can say that AB is greater than frequency of A into frequency of B upon N. Therefore, attributes A and B are associated. Next example. For the following data, find out whether the attributes A and B are independent, associated or dissociated. Exactly parallel problem we have. Frequency of A is given as 150. Frequency of alpha is 250. Frequency of B is 200. And frequency of alpha B is given as 125. So we will find the remaining class frequencies by writing the values in the tabular form as A alpha total, B beta total. So they have given us frequency of A is equal to 150. It is given. Frequency of alpha is also given as 250. So 150 plus 250 will give us the value of N. So N value is nothing but 400. Frequency of B is 200 given to us. So beta can be calculated as 200. 400 minus 200 will give you 200. Now one more frequency they have given us, alpha B. So alpha B value is 125. So 200 minus 125 will give you 75. 150 minus 75 will give you 75. 75 plus 125 will give you 200. So to check the condition, we need the 4 values. Frequency of A is 150. Frequency of B is 200. Value of N is 400 and frequency of AB is equal to 75. So find out the value of frequency of A into frequency of B upon capital N. 150 into 200 upon 400. If you solve it further, 0 and 0 is cancelled with 0, 0. 4, 2 ones are 2 twos are and 2 ones are 2 75s are. So the value becomes 75. And the given value of AB is also 75. So what can we say? We can say that as A into B upon N is equal to AB. This condition is satisfied. Attributes A and B are independent. Next example. For the following data, find out whether the attributes A and B are independent, associated or dissociated. Same type of problem we have again. So N is equal to 10,000. Frequency of class A is equal to 4,500. Frequency of class B is equal to 6,000. And frequency of class AB is equal to 3,150. So these 4 values are given. Check the condition. Frequency of A into frequency of B upon N. So 4,500 into 6,000 divided by 10,000 will give us the value 2,700. But our value of AB is 3,150. So as AB is greater than frequency of A into frequency of B upon N, therefore attributes A and B are associated. We can say positively associated or just associated. Next example. From the following ultimate class frequencies, find the frequency of the positive and negative classes and the total number of observations. So 4 frequencies are given to us. Frequency of class AB is equal to 100. Frequency of class alpha B is equal to 80. Frequency of class A beta is equal to 50. frequency of class alpha beta is equal to 40. And we have to find frequency of class A, frequency of class alpha, frequency of class B, frequency of class beta, and N. So we'll write the given frequencies in the tabular form as A alpha total, B beta total, and value of N. See the given things. Value of AB is given as 100. So replace AB as 100. Alpha B is given as 80. So alpha B we will replace by 80. A beta is 50. So A beta we will replace by 50. And alpha beta is 40. So alpha beta we can write as 40. Now find out frequency of A. So AB plus A beta will give us frequency of A. So 100 plus 50 is 150. Then 80 plus 40 becomes 120. And 150 plus 120 becomes 270. Same way, 100 plus 80 is 180. 50 plus 40 becomes 90. And 180 plus 90 is 270. We can use the relation between class frequencies as frequency of A is equal to AB plus A beta. So frequency of A is equal to 100 plus 50. So frequency of class A is 150. Same way, to get frequency of alpha, alpha B plus alpha beta will give you frequency of class alpha. So 80 plus 40. So alpha frequency of class alpha is nothing but 120. Next, frequency of class AB plus frequency of alpha B will give us frequency of B. So frequency of class AB is given as 100. Frequency of class alpha B is 80. So frequency of B can be considered as 180. Then A beta plus alpha beta will give us the value of beta. So A beta frequency is 50. Alpha beta frequency is 40. So we can say that the frequency of class beta is 90. Then we know that A plus alpha is equal to N. So value of A is 150. Value of alpha is 120. So value of N becomes 270. Or similarly, B plus beta is also N. 180 plus 90 is equal to N. Therefore N is equal to 270. Next example. Are the following data consistent? Justify. N is equal to 150. Frequency of class A is 50. Frequency of class B is 80. And frequency of alpha beta is 10. So we have seen that whenever we want to test the consistency of data, we need the value of AB. So we will find the value of AB using the tabular form as A alpha total, B beta total, and N. Value of N is given as 150. So replace this value of N as 150. Frequency of class A is 50. Natural frequency of class alpha we can calculate as 150 minus 50 is 100. And frequency of alpha beta is given as 10. So this frequency is given as 10. Frequency of B is 80. So we will replace frequency of B as 80. We know that 100 minus 10 will give you 90. So alpha B frequency is coming to be 90. But if you calculate AB is nothing but B minus alpha B. So 80 minus 90. So alpha B is coming as minus 10. So as AB is equal to minus 10, the data is not consistent. Or we can find the value of AB using the relation between the class frequencies. Alpha beta. Alpha beta can be written as N minus A minus B plus AB. So replace all the values in the equation. Alpha beta is given as 10. Value of N is given as 150. Frequency of class A is 50. Frequency of class B is 80. And we have to find the value of AB. So we will keep AB as it is. So 10 is equal to 150 minus 50 minus 80. So this 150 minus 50 becomes 100. 100 minus 80, the value becomes 20. So AB is equal to, if you take this 20 on this side, so AB is equal to 10 minus 20. So AB is coming as minus 10, which is less than 0. So data is inconsistent.